Hi, today I am going to discuss the Meissner effect. So, what is this Meissner effect in superconductivity? Suppose you take a superconductor. The temperature is below the critical temperature. You allow some of the magnetic field lines to go through it. But an amazing thing is observed. When you try to put some magnetic field through it, the magnetic field lines become like this, like this, like this. If you give a short recap from the properties of ferro, dia, and paramagnetic materials, I think you remember that for a diamagnetic substance, the magnetic field lines cannot go through the material. So you can say a superconductor acts as a diamagnetic material. This property shows its diamagnetism. It's a diamagnetic material. You can do another thing. In this case, you took the superconductor and allowed some of the magnetic field lines to pass through it. Now, let's take this superconductor to a region where there are magnetic field lines. Suppose these are magnetic field lines and this be a superconductor. Same thing will happen. The magnetic field lines will become like this. So you can take a normal superconductor and can allow magnetic field lines to pass through it. You get its diamagnetic property. And if you take a normal superconductor in a region where there are many diamagnetic fields, I mean a region of diamagnetic field, the superconductor will show its diamagnetic property. So it will act as a diamagnetic material. So a superconductor is a diamagnetic material. Let's do some mathematical calculations. We can conclude that the magnetic field inside a superconductor is 0. If you recall a formula from your electromagnetism course, you will get this relation. Let me explain you the terms and what actually happens in these things. Okay, I am explaining through this. If you take a normal superconductor, you give some of the field lines to pass through it, it will act as a diamagnetic material and no field lines will be allowed to pass through it. This is Meissner effect. So let the magnetic field intensity applied outside is given by HA, and you know from the law of electromagnetism, if you apply flux through this, an opposite flux will induce, that is, a surface current will be induced, and it will try to cancel this magnetic field lines. And this is the induced magnetization. It is also defined as the magnetic dipole induced per unit volume. So obviously this tries to cancel out and the field lines go in this fashion. This is the external magnetic field intensity. This is due to the surface current induced due to the magnetic flux, external magnetic flux, and this B is the magnetic field inside the superconductor, which is 0. So we take 0 equals to mu naught J plus Ma, which equals to Aj equals to M minus A. You know this step. And for magnetic susceptibility, which is defined as the ratio of magnetic dipole moment induced per unit volume to that of the external magnetic field intensity, it will be given by minus Ma minus M, which equals to minus 1. And you know mu r is mu. The susceptibility minus 1 means this is diamagnetic material. This value comes under the range of the diamagnetic material. So you can say, you know this relation, magnetic susceptibility is equal to relative magnetic permeability minus 1. So here magnetic permeability, relative magnetic permeability is equals to 0. You can define magnetic permeability as the magnetic permeability to that of magnetic permeability in vacuum. This is magnetic permeability in the medium, which equals to magnetic field to that of magnetic field in vacuum. So this is magnetic field in the material over here, and this is magnetic field in the vacuum, that is this applied, it's in vacuum. So this will be B equals to mu r dA. You can also see this equals to 0. This is all about Meissner effect, and this gives rise to a property of superconductor, which is the magnetic field inside a superconductor is 0. This is all about Meissner effect. You can have a look at it. So this is all about Meissner effect. Thanks for watching the video.